Okay, hi. Now we're going to find equation in a different way. We're still being given some points, but these points will be different, and because of it, our analysis will be different as well. Now, what is given is the x-intercept and one more point. This one more point, it can be another intercept, it can be the vertex, it can be any point as you want. Okay. So in my example, I have x-intercepts, negative 2, 0 and 5, 0. And the point that's given to us is the coordinate 2, 3. Like x is 2 and y is 3. Like this doesn't seem to make any sense from where I got this point. It's just something that I made up, to be honest with you. But let's see what function is described that goes through all of these 3 points. First of all, to have a little bit of understanding of what it should be, well, let's map this out in a coordinate system. I have x-intercept negative 2, 0. So if this is my x and this is my y, I have negative 2, 0 is here. The other x-intercept, 5, 0, well, 1, 2, 3, 4, 5, that's here. This point that's given to me, 2, 3, okay, let's see where this ends up. So x equal to 1, 2, and y is equal to 1, 2, 3. So that's up here. So I don't know if this point is the, what is it? Is it the vertex? Is it some sort of weird symmetry point in some other way? I have no idea. I just know that the parabola will somehow go through these 3 points. So, I mean, I could find out by knowing that this is x equal to negative 2 and here is x equal to 5. The axis of symmetry must be exactly in the middle between these 2 points. Otherwise, it wouldn't be the axis of symmetry. So what is the average value between negative 2 and 5? Well, negative 2 plus 5 divided by 2, that's the average value, right? I have negative 2 plus 5, that's 3 divided by 2. So that's 1.5. 1.5 is actually very close to 2. So 1.5 is somewhere here. So the axis of symmetry would be here, x equal to 1.5. This is the axis of symmetry. Symmetry, okay. So if I were to graph this parabola, the vertex, just by looking at it, is going to have to be somewhere up here, and I extend down in both directions. So just by knowing these 3 values, I can actually graph the entire parabola. So it would be something that looks like this. Something like this. So can you see how easy it is to graph a parabola without doing the table of values? I'm saving maybe 10 minutes actually. And this is crucial information when I'm writing a test, because just to getting the x-intercepts and to get another point, any point, I can already graph the whole thing. All right, so let's see if we can get the function going here. Because I have x-intercepts in these two points, I'm going to use the null factor law backwards. I know that the quadratic function y, it's going to have to be something where negative 2 gives me a 0. So I need x plus 2, because negative 2 plus 2 is 0. I am also going to need another point where 5 gives me 0. So I need x minus 5. Why? Because 5 minus 5 is 0. So I would get a 0 here, which would give me a 0 here in y. So this is the null factor law backwards. I can also multiply everything by a number a. I don't know which number this is. But if any of these 2 is 0, then 0 times a number, it's still going to be 0. So y is 0. It still works. So the job is to find this a. What is this a? So, question mark. Well, let's use this given point to try to find what this number a is. I know that when x is equal to 2, I have my y is equal to 3. So y is equal to 3, I replace the y with the 3. It's equal to a, that was some mystery here, I don't know what this is. X is equal to 2, so 2 plus 2 is 4. And x was still equal to 2, but 2 minus 5 is now negative 3. 2 minus 5, negative 3. So it gives me x equal to 2 here, gives me these 2 numbers, and I know that y has to be equal to 3. I still don't know what a is, but I can solve this now to see what happens. These two guys gives me negative 12, 4 times negative 3. So I have a times negative 12. So a multiplied by negative 12. Let's now divide both sides by negative 12. 3 divided by negative 12. A times negative 12 divide by negative 12. So once again, these two cancel out. But I have a 3 divided by negative 12 on the other side. Well, 12 is 3 times 4, so the 3's will cancel out. If you do this carefully, you can do this carefully if you want. I'm just going to write down the answer. It's negative 1 over 4. Yeah? 3 divided by negative 12. And this is equal to, well, on the other side, only a survived. So I actually found my a already. So this means, let's do this little arrow here, that y is equal to this a, which was negative 1 over 4, times x plus 2 times x minus 5. And in a way, I am done here, but I want to write it out as ax squared plus bx plus c. So if I compare this with y equal to ax squared plus bx plus c, my question still remains, what is b? Or what is c? Everything is actually given to me already. This is just a factorized version of what is written down here. So if I FOIL this out, if I expand these two brackets, then hopefully I will be able to find my a's and b's and c's. So let's do this. We have y equal to negative 1 over 4. That's just going to stay here in the front. Now, x times x, that gives me x squared. X times negative 5, that's minus 5x. 2 times x, that's, well, plus 2 times x. And 2 times negative 5 is negative 10, close bracket. Negative 5x plus 2x, that's equal to negative 3x. And then let's multiply in this 1 over 4, this negative 1 over 4 everywhere. We have y equal to negative 1 over 4 times x squared. That's negative 1 over 4x squared. Okay, no mystery there. Here I have negative 3x, so negative 1 over 4 times negative 3. The negative multiplied by a negative cancel each other out. I get a positive. 3 multiplied by 1 over 4, so that's 3 over 4 times x. And the last multiplication to do, this is 1, 2, 3. This guy remains in the back. Negative 1 over 4 times negative 10, that's positive 10 over 4, which can be simplified, because this is 10 is 5 times 2, 4 is 2 times 2, so these two factors of 2 cancel each other out, so I have a 5 over 2 left. So the final answer is y equal to negative 1 over 4 x squared plus 3 over 4 x plus 5 over 2. Please notice that when I am writing these answers, when I write something like this, what I mean is negative 1 over 4 multiplied by x squared. I could also have written negative x squared over 4. I could also have written negative x squared upstairs entirely and having it all divided by 4. This all gives me the same answer. Plop in any number in these guys here, and you multiply by 1 over 4, so 0.25, and take a negative sign in front, you get the same answer in this term as you would get in this and in this. This is just the different ways of writing the same thing. And the same thing goes for this guy, of course. Okay, so I am done. This is my answer. I can write A-N-S-W-E-R. The answer goes here. I have a big happy face there, and I get my marks for the test. So, easy, no? Okay, bye.